Okay, I think we're good to go on this one. So today we're going to be starting chapter 3. Chapter 3 is all about quadratics and quadratic functions and equations. Some complex numbers thrown in and a little bit of other stuff, but for the most part, it's quadratic functions. So today we'll be looking at 3.1, which is quadratic functions and models. So first of all, quadratic functions, we need to figure out what a quadratic function actually is. And a quadratic function is similar to a linear equation in form, but adds an x squared component. So basically, you will see x squared somewhere in a quadratic function. So that's a linear equation. That right there, the 2x squared plus 3x minus 4 is a similar equation. It still has the 3x minus 4, but we've added this 2x squared, which makes it a quadratic. So the main thing that you want to see to determine a quadratic function is this bit right here, this x squared. If you see like an x cubed thrown in there, that will be different than a quadratic equation. That's no longer quadratic. It is further down the line, and we don't usually have special names for those. They're just nonlinear. So the structure of a quadratic function is summarized right here. You've got f of x equals ax squared plus bx plus c. The only rule for something to be a quadratic is that a cannot equal 0. Oops, cannot equal, here we go, 0. You could have 0 for b and 0 for c, so like you could have f of x equals 2x squared. This is still quadratic, or even just f of x equals x squared. Doesn't really matter. These are both quadratic equations, even if they don't have the extra stuff attached. So you can also rearrange the terms, but the ax squared term must exist for a function to be quadratic, so that a can't equal 0. If this is equal to 0, then it doesn't work. You could have potentially like 3x plus 2x squared minus 1. That's still quadratic. It still has the x squared component, so that one's fine. A little bit of practice identifying quadratic functions. So this is, I think there's some questions in your homework that are going to be about identifying quadratic functions, but this shouldn't be too difficult. You're really just looking for an x squared. So you're going to identify these as either linear, quadratic, or neither. Now this one is meant to be tricky because it's got this negative 2 squared x plus 3. And when written like this, it actually simplifies to negative 4x plus 3. I know that you're probably thinking that negative 2 times negative 2 is positive 4, so this should be a positive 4. But since order of operations is funny, this is effectively the same thing as this. And 2 squared is 4. You'd have to have this in parentheses to square the negative part. But anyway, so that one's linear. This one right here, we've got 2 plus 3x minus 0.1 x squared. You see an x squared, you know it's quadratic. That's that. As long as there's not, actually, that's not entirely true. If you see an x squared in the simplified version of the equation and there is no x cubed or anything bigger, then it is quadratic. So this one contains an ax squared term, so it is quadratic. The reason that I corrected myself on the last one, we have 1 over x squared minus 3 right here. There is an x squared, but not really. If we simplify this, remember, this is basically x to the negative 2 minus, well, actually, it's this 1 times x to the minus 2 minus. I'm actually not sure how you'd write this as a, but this, when it's on the bottom, is equal to x to the negative 2. So here we go. 1 times negative 1. That's the simplified version of it. I think that works. Anyway, so yeah, this one is neither linear nor quadratic. So yeah, like it says here, remember that 1 over x squared is equal to x to the negative 2. So that is not an actual x squared term. All right. Hopefully that made some sense. So hopefully you guys already know what graphs of quadratic functions look like. They result in a parabola, which is always a fun word. If the parabola opens upward, as it does here, then you know that the a value is going to be positive in your ax squared. So whatever the a is in front of the x squared, it's going to be positive if this opens upwards. If this opens downwards, then it's going to be negative. So that just tells you whether the a value, this number right here, is positive or negative. It doesn't really tell you anything else. You'd have to actually calculate it, which we will learn how to do in just a bit. So the first thing we need to look at is the vertex. So the point at which a parabola reaches its minimum if a is positive or its maximum if a is negative is called the vertex. So if we go back and look at these graphs, the vertex is this spot right here. This is a positive a value. It opens upwards. So the minimum value is the vertex. In this case, the maximum value, this is a negative a. So the maximum value that it hits, that's our vertex right there. And the vertex can be kind of difficult to identify when we write our function as ax squared plus bx plus c. If you just have like 3x squared minus 4x plus 2, it becomes really difficult to tell where the vertex is actually going to be in your function. But there's another way of writing quadratic formulas or functions, which is called vertex form, and it uses this. So it's f of x equals a times x minus h squared plus k. And the reason this is useful is when written in this form, the vertex is located at the point h comma k. So effectively, this would be the x coordinate of your vertex, and this would be the y coordinate of your vertex. We're going to talk a little bit more about how to write equations like this in just a second. So using vertex form. First up, let's practice using vertex form to identify a vertex. So here we have a quadratic formula or a quadratic function written in vertex form. It is f of x equals -2 times x minus 1 squared plus 3. So remember that we are looking for an h and a k. And this is going to be our h value because it's x minus h in the overall formula. Actually, here, it might be worth writing out the general formula. Equals a times x minus h squared plus k. Now you'll notice that this sign is negative. So this is important because that means that the h value is going to have the opposite sign of whatever this is, right? So in this case, we have x minus 1. That means that h is positive, right? If we had x plus 1, that would mean that x or h is negative. But in this case, since we have the minus, this is a minus. Just delete it again. Since this is a minus, we have a positive 1 for our h, and we have positive 3 for our k. So the vertex should be 1, 3. And then we're asked, is this vertex a minimum or a maximum? So the way to figure this out is we use our a value. Once again, we're going to do f of x equals a times x minus h squared plus k. So we found our k value here, found our h value here, which means that our a value is right here. And since a is -2, that means that our graph opens downward, which means that our vertex is a maximum. So the answer should be maximum for this. All right. Next up, we've got writing the equation of a parabola. So this is when you have a parabola on a graph, or when you're given the vertex and at least one other point, we can write the equation for a parabola. So let's see how to do this with a parabola that has a vertex at the point 2, 3 and hits the point 0, 1. And to start, we're actually going to write this in vertex form. So we're going to use vertex form to write out our quadratic equation here. Remember, f of x equals a times x minus h squared plus k. So we can already fill in h and k. The vertex, remember, this is h, this is k. So we should go f of x equals x minus 2 squared plus 3. Then all we have to do is plug in the other point that we have. So in this case, we have 0, 1. So we'll plug in 0 for x. That'll go here. And then 1 will be our y value. So 1 will go here. And when we do that, we get 1 equals a times 0 minus 2 squared plus 3. So we solve 0 minus 2, that's -2, squared is 4. So 0 minus 2 squared is 4 plus, or we have, yeah, sorry. 0 minus 2 squared is 4. So we subtract 3 from both sides, and then we're left with negative 2 equals 4a. And then once we simplify that, we divide both sides by 4, we get that a is equal to negative 1/2. So then all we have to do is plug this back into our equation, and now we have f of x equals negative 1/2 x minus 2 squared plus 3. Okay, I'll probably run through some examples of how to do this in class at some point, because I think it'll be valuable to see that. Now let's talk about how to convert back into standard form. So this ax squared plus bx plus c. And it's actually really not very hard. All we have to do is FOIL out our x minus h terms and then distribute a, which is fancy math talk for do calculations you've probably done 100 times. So in this case, we have f of x equals 2 times x minus 1 squared plus 3. So let's start by FOILing x minus 1 squared. And that equals x minus 1 times x minus 1. And if you've forgotten what I mean by FOIL, that means first, outside, inside, last. So we're going to multiply all of those different things. We get x squared minus 2x plus 1 when we do this. So now we have f of x equals 2 times x squared minus 2x plus 1. And then we want to distribute our 2 to all three of these. When we do that, we get, oh, there should be a plus 3 at the end, sorry. And then when we do that, we get f of x equals 2x squared minus 4x plus 2 plus 3. We simplify those two terms. We've got a plus 2 and a plus 3. That makes it plus 5. So we get f of x equals 2x squared minus 4x plus 5. And in fact, that is our answer. Wrote it down ahead of time to make sure I get the right one. So next up, we've got the vertex formula. So when we want to convert the other way, when we want to go from a standard form quadratic equation into a vertex form quadratic equation, it's a little bit complicated, and we need to know how to find the vertex first and foremost, because that's going to be really important. One of the ways you can do it is by graphing or by writing out a chart of all the table of values. That's a huge pain and it takes a long time. So instead, one of the things that we want to be able to do is use the vertex formula. Now, if you want to see the derivation of this, it is in your textbook. I can also talk about it in class, but honestly, it takes a long time to do, and it's not particularly useful to know how we get this. But it is important to know that the x value of the vertex is equal to negative b over 2a. So remember, we've got f of x equals ax squared plus bx plus c. So we would take our b and we would put it over 2 times our a, make it negative, and that would give us our the x value of our vertex. Then all we have to do is plug this x value back into our quadratic equation, and we can solve for the y value. So in this case, we're going to try it with f of x equals 3x squared plus 12x plus 7. So we've got negative b over 2a, negative b over 2a. The negative can be over here. It doesn't really matter where the negative is. And in this case, our b is 12. So we'll have 12 over, and then a is 3. So we've got 2 times 3. That is equal to negative 12 over 6, which equals negative 2. So we know that our x value is equal to a negative 2. We plug negative 2 in for x. So then we have f of x equals 3 times negative 2 squared plus 12 times negative 2 plus 7. When we solve for this, we get 4, which is 4, or negative 2 squared is 4, times 3 is 12. That's plus, or a positive 12 times a negative 2, that gives us negative 24. And then we've got plus 7. So we add these together, we get negative 5. So that means that the y value is equal to negative 5. So our point should be negative 2 comma negative 5. And since this is a positive a value, just for practice sake, we will know that this is a positive opening parabola. So this is also the minimum. So -2, comma, -5 is our answer. Now that we have an easy way to solve for our vertex, we can actually convert all the way from standard back into vertex form. So we're going to use the same problem again, and we just calculated out that vertex to be -2, comma, -5. So we'll use this point. So now that we have this is our h value, this is our k value right here. So we've got f of x equals, let's remember that this is written as f of x equals a times x minus h squared plus k. So in this case, we've got f of x equals, now we already know our a, that's 3, that stays the same, times x, now it's minus -2, so we're going to do plus 2, parentheses squared, and then it's plus our k, which is -5, so minus 5. So this should be our answer to this one. And then if we want, we can calculate it back just to double check and make sure. So if we FOIL this out, we've got x plus 2 times x plus 2. This is the answer, but in order to check it, we can factor this back out, convert back. X plus 2 times x plus 2 gives us x squared plus 4x plus 4. It's kind of convenient. So we have 3 times x squared plus 4x plus 4 minus 5. Oops, plus 4. Getting ahead of myself. So if we distribute that out, we have 3x squared plus 12x plus 12 minus 5. 12 minus 5 is 7, so we get 3x squared plus 12x plus 7. And that is, in fact, our original equation. So we know that we got our answer right. Okay, converting to vertex form part 2. We can also convert to vertex form by completing the square. And this is a little bit trickier. Okay, and I didn't leave myself any hints, so cool. We're going to do this the old-fashioned fun way. So the first thing we want to do is we want to complete the square. Now, when you're completing the square, you know that your x value, whatever this is divided by 2, is going to be what you have on the other side. So we're going to have x plus 3 is what's going to be squared. But if we factor this out, we're going to get not minus 3, so we need to figure out what we do differently here. So the easiest way to do this is first move the 3 to the opposite side. So set the whole thing equal to 0 usually. X squared plus 6x minus 3. We add 3 to both sides. Give us 3 equals x squared plus 6. And then since we know that we're going for half of this, we've got x plus 3 is what we want squared, and that's going to give us 9 when we're done. So we add 9 to this. And in order to do that, we need to add 9 to this side. So now we get 12. So we have 12 equals x plus 3 squared. And then we subtract 12 from both sides. And that'll give us our f of x equals x plus 3 squared minus 12. So we're definitely going to have to go over this one in class because I don't feel like that was very clear at all. Hopefully you remember how to complete the square. If you don't, we're actually going to get a lot of practice with it in the next section. But I'll also go over this a little bit more when we do our in-person classes the next couple of days. So we have f of x equals x plus 3 squared minus 12. We can double check this once again by solving everything out. So we have x plus 3 times x plus 3. This time there's no a value, so that's kind of nice. FOIL this out, we get x squared plus 6x plus 9. And then f of x equals that minus 12, because we've got this minus 12 over here in our answer. This is the answer, by the way. I got to circle those. So we have the minus 12. 9 minus 12 is negative 3. So we have f of x equals x squared plus 6x minus 3. And that is our original equation. So check. Okay. Last couple things, graphing quadratic equations. Hopefully you know how to do this. This should be not particularly difficult. All you're going to do really is solve for x and y points, just like you would in a linear equation. The difference is you need to make sure to include your vertex. So when you're choosing your points, you're finding your vertex is really important. And remember that the vertex, the x for the vertex is equal to negative b over 2a. It's going to be really important to remember this formula. That's going to be really, really helpful for all of your stuff. So if you're taking notes, I would definitely write this down. It's for vertexes specifically. But anyway, vertices. I think that's plural, whatever. If you're unsure of what numbers to make sense to start with, you can always calculate your vertex using the vertex formula. So the reason you want to do this is something that I'll display in a second. But basically, you want to make sure that your points are all close to the vertex because it's going to give you something really cool when you write it out. So we're going to graph g of x equals 2 times x minus 1 squared minus 3. Now remember that our vertex formula is f of x, or in this case, g of x equals a times x minus h squared minus 3. So our h coordinate, again, since this is still a negative sign, we know that h is going to be positive. So we've got 1, and then our y coordinate, oh, whoops, this is k. That's a k. So we've got 1 is our h, and negative 3 is our k in this case. So we're going to start with point 1 and negative 3. Now you might be wondering why I picked to start this one in the middle, and you're going to see in just a second. Now I want to try the point 0, or x of 0. I'm going to try x of negative 1, try x of 2, and I'm going to try x of 3. So if I plug in 0, I get 0 minus 1. That squared is positive 1. So we have 2 times 0 minus 1 squared. This is equal to negative 1. Negative 1 squared is 1 minus 3. So now we'll have 1 times 2, which is 2, minus 3 equals negative 1. So here we have a negative 1. Then we're going to try negative 1. So now we have 2 times negative 1 minus 1 squared minus 3. Negative 1 minus 1, that's negative 2. Negative 2 squared equals 4. So we have 2 times 4 minus 3. And that is going to give us positive 5. 2 times 4 is 8. 8 minus 3 is 5. Now on the other side, if we do 2, we get 2 minus 1. 2 minus 1 is 1. 1 squared is 1. 1 times 2 is 2. 2 minus 3 is negative 1. And if we do 3, 3 minus 1, that's going to be equal to 2. 2 squared is 4. 4 times 2 is 8. 8 minus 3 is 5. Now you'll notice that your y values are symmetrical around your vertex, singular. This is what you're going to see whenever you have the vertex in the middle. So it's easiest to pick your x points as the x coordinate of the vertex and then the points on either side of it. Plus, when we're actually graphing, what this will let us do is if we start with that vertex, so at 1, negative 3, it's right here, then it's really easy. We can graph on both sides. So we've got a 0, negative 1, and we've got a 2, negative 1. And then we've got a negative 1, 5. So that's way up here. I just deleted everything. Okay, let's do this again. I'm just going to write the values in because I remember them. 0, negative 1. Why is it dual writing now? It's not good. Oh, it's mirroring everything. Hopefully that fixed it. Okay. 2, 3, this is 5, this is negative 1, this is negative 3, this is negative 1, and this is 5. So if we're graphing that, we've got this point, we've got this point, we've got this point, got this point. That was terrible. And we've got this point. And then all we do is draw our parabola through here. It's a really skinny parabola, and it'll keep going like this. So it'll look something like that. That's obviously not very well drawn, but you get the idea. And again, we want to notice that these are symmetrical around our vertex. Struggling to draw things today. All right. The last thing we're going to look at is a really difficult word problem. For Math 111, they usually use this as a task. So it's supposed to be like a project you work on your own for like an entire day. I think that it's going to be more worth it to see this as like a walkthrough problem for this situation, especially because you can't work in groups right now. Well, you're not supposed to be able to work in groups right now. Most of you can. But anyway, what this says is that a rancher is fencing a rectangular area for cattle using the straight part of the river as one side of the rectangle. The rancher has 2,400 feet of fence available. What are the dimensions of the largest possible area he could fence off for his cattle? So basically, drawing this out, we've got a river. This is the river. And he is building a fence like that. And he has 24 feet or 2,400 feet of fence. He wants to maximize his area. So a couple of important formulas here. Area of a rectangle equals length times width. Hopefully you guys all already know that. The other thing is perimeter. Usually perimeter is length times 2 plus width times 2. But in this case, since one of the lengths is going to be taken up by the side of the river, we don't need a second length. So perimeter is going to be L plus 2W. Now, which is also equal to 2,400. And then this we want to maximize. Okay, so what we need to do is we need to set up a quadratic equation calculating for A that will allow us to calculate a vertex. I keep saying that weirdly. So the first thing to do is to move around the perimeter formula. So if we say that length plus 2 width is equal to 2,400, we want to solve this for one of our two variables. I think it's going to be easier to solve this for length. So what we'll do is we will say that length is equal to, subtract 2w from both sides, we get 2,400 minus 2w. Okay, then we can go up here where we have an area formula, which is length times width, and we can sub in this whole thing for our L. So we'll have A equals 2,400 minus 2w times w. Okay. When we solve this out, we get negative 2w squared. I'm rewriting this side on, or this one on the other side, plus 2,400w. And you'll notice that this is now a quadratic. More importantly, it's a quadratic with an a value that's negative, which means it opens down like this. And since it opens down like this, we know that wherever our vertex is, that's going to be a maximum. So we need to calculate our vertex, and remember that the vertex, the x value of the vertex is equal to negative b over 2a. So in this case, we would do negative 2,400 over 2 times a, which is negative 2. That's negative 4. So the negatives will cancel. We get 2,400 divided by 4. 2,400 divided by 4 equals 600. Now 600 is the x value of our vertex, so of our maximum, which leaves the other value in this case as 1,200. So for us, 600 is w. If we solve for this, it would be some really gross number. You probably don't want to do it all the way out. But what we get then is the easier way to solve it, honestly, is to plug that in here for length. So 600 is our w. We have 2,400 minus 2 times 600. That's 1200. 2400 minus 1200 equals 1200. So our width is equal to 600 feet, and our length is equal to 1200 feet. And you can double check to make sure that works by plugging in 600 for each of the W's here. So 600 plus times 2 plus 1200 does in fact equal 1400 or 2400. So that's how you solve this one. Okay, that was all probably a little bit confusing. Luckily, we are now starting our in-person classes. This week it'll be 2 days a week. Starting next week it'll be 4 days a week. So we can get a lot of clarification. We can go over some example problems. Hopefully that will help clear it up a little bit more. But I've already taken up plenty of your time today. I think that's the last thing. It is. Okay. So I will see you guys later.